Hey, manufacturing world, welcome to another episode of Shop Matters, sponsored by Okuma America. This podcast is designed to talk about all things manufacturing related. I'm your host, Wade Anderson. Joining me today in the studio, I've got Jack Rushlander from Jergens and Arie Thompson from Gosiger Automation. Thanks for joining us, guys.
Thank you.
All right, so Jack, lead us off. Tell everybody that's listening a little bit about Jack.
Well, I'm Eastern Technical Manager for Jergens Workholding, and I've got about 40 years experience basically figuring out how to hold parts for manufacturing. And that's what I do all day long, and anything east of the Mississippi, different companies that Jergens is working with. My typical day for me is to go around looking at people's manufacturing opportunities and helping them figure out ways to hold it so they can machine it.
All right. You can't machine it if you can't hold it.
That's right.
Very good. All right, tell us a little bit about yourself.
Yeah, I'm Arie Thompson, Director of Sales for Gosiger Automation. Really started at Gosiger Automation in inside sales or application engineering, worked into some mechanical design roles, designing custom systems back before we had the automation within Reach Group. So I've really grown through the ranks pretty quickly at Gosiger, but times are changing and everybody in the industry is looking more for automation to supplement their workforce and aid their throughput. So doing more with less.
Yeah, absolutely. That's kind of the main buzzword right now, right?
It's a good way to put it, Arie.
Yeah. So most recently, the last time I saw you guys and all three of us were together was actually at Geyserfest.
Yeah.
So what a great event that was. Pretty exciting. Do you recall the total head count that was there that weekend?
I don't know the exact head count. I know we had north of 1,000 customers through over the course of 2 days. I think that puts us pretty much on track to be probably the largest privately held machine tool show in the country. We had about 70 vendors and 20 on the waiting list. Just quite frankly, we ran out of space in our campus environment that we have. But a lot of technology on display, anything you could think of from a cutting tool perspective or manufacturing perspective, and then also 3 buildings full of automation, from standard automation and our load and goes all the way up to custom automation. On multi-machine, multi-robot, linear gantry cells, as well as floor-mounted custom cells for various customers.
Yeah, I think that's an interesting point when you think about just the amount of technology that was shown, not only from the cutting tool or the machine cutting standpoint. I go to machine tools. I first go because I want to see the equipment. I like looking at machines. I'm a machine geek. But then I want to get down to, okay, what's the new stuff? What's new things that Jergens bringing out? What's the new cutting tool technologies? What are they doing from a programming standpoint? And with that many vendors, 70 different vendors, and a lot of them tied into demos on the machines, it was almost mind-boggling how much stuff you could see. Every machine had some unique features. So,
yeah, that's a nice size show too, because over all the years I've been in it, it's a large enough show that you've got good quality vendors there. But it's not so large that it's intimidating, like going to an IMDS or something where there's just so much to see that you just end up running through the aisles trying to see it all. Mm-hmm. But I like that show. It was a very, very class act.
Yeah. So I got to talk to a lot of customers over the course of the couple of days that I was there, and you'd mentioned 3 buildings full of automation. It goes without saying that not only just Gosiger per se customers. There were customers there from other territories and other areas as well. And everybody that I talked to, automation was the big word. Every customer that was there, they all had something to talk about automation, or the fact that they don't think they can automate, but they're trying to figure out, they know they got to get there. So, through the pandemic and just the job market the way it is, trying to find people, and this goes long pre-pandemic, the biggest heartburn I always hear from customers trying to find good help, and that's repetitive, everywhere I go.
Yeah, one of my questions when I go into an opportunity is I say, hey, if I was magic and I could do anything you wanted, what would it be? And I'll bet probably 75-80% of the time right now I get, find me good people.
Yeah, yep.
Is the answer I'm getting.
And now they're realizing a lot of times the good people looks like a yellow or orange piece of equipment in front of that machine, right? So
he never calls off, and he never gets sick, and he doesn't have any problems. You don't have to wear a mask either.
Right.
To that point, last week I gave a presentation at WMTS, which is the Wisconsin Machine Trade Show, talking about specifically that every customer in the or shop owner in the country is looking for skilled workforce. They're just not out there unless you're stealing them from somebody or you're grooming them, right? But those people take years, to get to the point where they're really self-sufficient and somebody that's a true contributor to the team. So how do you do that more quickly, without without being able to find those people? So you're really investing in, whether it be AWR or some of our custom automated cells, you're investing in that technology from an automation perspective to amortize that skilled labor that you currently have over multiple work cells, as we call them. So you're taking rather than it's truly a paradigm shift, quite honestly, as far as going from one operator, one machine type work centers to one operator being able to service 2, 3, 4, and sometimes up to 6 or 7 cells. When you start getting into that 4, 5, 6 cells, even with small setups, in the where your lot sizes are into the 50 to 100 piece range, that changes things significantly for a job shop manufacturer. A lot of the larger manufacturers throughout the country have already been on this wave of automating, right? And amortizing that skill set that they have, that operator skill set over multiple pieces of equipment with the automation. But the job shops, the smaller manufacturers, they're just now dipping their toe into the water. So when you start talking about, hey, I hear time and time again that my lot sizes are too small. Well, what are your lot sizes exactly?
Right.
And they say, well, about 100 pieces. That's fine. We can automate that. We automate that all the time, especially with AWR, automation within reach, where we have flexible part contact tooling, adjustable drawer inserts. So that and you can quickly and easily call up different programs via the HMI rather than calling up, remastering the robot. And reteaching points, it's very quick. Changeovers are minutes rather than tens of minutes or even hours. So you can do those 50-piece lot sizes, 100-piece lot sizes, very quick and easy. It's really, is it a reoccurring order? Is it an order that you see multiple times over the course of a year?
Yeah, even if it's small quantities, but it's reoccurring, then it's easy enough to go back to. So while we were at Geyserfest, Jack and I, we were leaned up against a cocktail table, right there in the middle of the floor. And that's kind of where some of this idea from this podcast came from is, we're just sitting there leaning on our elbows against the table talking about how does a guy take a machine that's not been automated or a process that's not been automated. Joe Schmo, Wade Anderson's been loading this part this way for the last umpteen years. How do you take that and that knowledge and the skill set that me or anybody's got to load those parts and make it in an environment that's automated? So you had brought up like some clearance things that you got to consider from your fixturing, workholding, and a clearance standpoint. Talk through your thought process on that.
What I typically do with a customer, and I look at it specifically from the workholding side, is I'll sometimes ask them, okay, show me how do you load this part into your current fixture, be it a vise, be it a collar chuck, be it a fixture, whatever it is. And I'll say, I just want to watch you load it. I want you to watch you load it and unload it a few times. And then I'll let them do it and I won't say anything. And I'll finally say, okay, now look what you just did. Subconsciously, you put the part in the vise with your left hand, and then you held it down against your Z-axis datum. You pushed it up against your Y-axis datum. You held it against your X-axis datum. You did all that without even thinking because you're a skilled machinist. And then you tighten your vise handle. And we got to do that with the automatic system. We have to do all those little nuances that you just did. Now, if you take that same situation and move it to a horizontal, where the guy's got, say, a tombstone vise or a fixture, and gravity isn't exactly your friend in a horizontal configuration, now you got to push a little harder and you got to think a little harder and you got to do little things just a little bit more involved. Same thing with a robot or an automation. But what I like about having the podcast and being able to talk about it like this is to I've been doing this for 40 years, so 25 years ago, people were so intimidated by even you mention the word robot. They were thinking about Star Trek or something. And I saw a little sign out here as I was walking around. It said, "Your dream is doable. It's delightfully doable." And I'm thinking to myself, that is a really good slogan for automation today, because it is doable. It's affordable. It's doable. You've got expertise out there now. You've got technology, and don't be afraid to ask about those 100-piece orders and those smaller quantities, because your dream is delightfully doable.
Yeah. Along the lines of like loading parts, one of the things we had talked about is even just when you put a part on and everything is so tight that the operator's loading it and he's got to, kind of give it a little vibration, a little jiggle to make it slide down on things correctly. Can a robot do that repetitively? Can you take that same fixture that this guy had this little intuitive way of giving a little jostle and make things fit? You got to rethink that, correct?
Absolutely.
Yeah, I explain it as you've got pre-clamping and clamping. A lot of times you got that anyway, pretty much. When you're holding that part with your hand, that's a pre-clamp.
Yeah.
But in an automated situation, you have to create that pre-clamping, and you can do it with spring plungers and different things to push the part, put pressure on it in certain ways. But you do have to duplicate all of that in the automated situation, and it is doable. There's little. I watched a situation one time, and many times I said, "Okay, show me everything you do to load this." And the guy gets it all loaded, and he takes a piece of shim stock and he sticks the shim stock behind his part and checks all his datums
to make sure he's got it all in there correct.
To make sure he's up against his datums. And I'm thinking, you have to do that every time? Yeah, because sometimes it moves. Or the guy that loads it, how many times have you seen a guy load something and then hit it with a hammer? What are you going to do? You want to buy a second robot and hit it with a hammer? So we got to build that all in. And it is doable. It can be done. But what I just make you tell people is really look at your process, kind of video your manual process, video what you're doing now, and then watch that video and think, okay, I'm going to have to do everything I see there somehow. And it can't be done. But if I was to stress anything when somebody's thinking about automation, I would say to really plan it well and think it out. Maybe you do almost like a flow chart type thing, where you just have it, plant every little nuance and every little movement that you need to do. You got to have a plan for it.
Yeah,
and that's what we're for. That's what you mentioned about holding it down. We've got ZPS units, 0-point position, where it definitely pulls the part back, and you can have things that push in from the side. They can be pneumatic, hydraulic, and you can sequence them with the PLC or whatever. But all that can be done.
Yeah.
And the cool thing about it now is it's very doable.
To your point, though, Wade, as far as what the operator is doing, as far as massaging that part onto the fixture, right? Because you have square corners and you don't have radiuses or lead-in chamfers on fixture locators. That's all critical, right? There's ways around some of that with technology and robots with force sensors and soft float. Some of those options that are provided by some of the robot manufacturers, but you don't want to get into that. A lot of those are increasing, adding some cost to to the overall cell or to the added programming of that, because that part has to be loaded, and really requires feel from the robot perspective to load that part over a tight tolerance fixture.
Yeah.
We like to eliminate that, right, if at all possible. So by adding, lead-ins or chamfers and, on the fixturing, so that it allows the robot and gravity to take effect, or even in a horizontal case where the robot just, loading it to a point.
Mm-hmm.
The robot will load to a point. You don't, and when you encounter sharp corners, that's when a fault occurs. So you want to eliminate those sharp corners and allow that robot to load that part, over that fixture, onto that fixture. And then, it loads to a point, then the fixture clamps come into place, and it, seats the part in a repeatable location. Relying on the robot for ultra precise, repeatable locating is not really good. You want the fixture to locate the part.
Yeah.
And sometimes there's even a requirement, after the load to come in, and probe the part for final positioning. Maybe it's, that tight of a load and that unique of a part that requires that more times than not. And I think Jack can talk to this.
Yeah, there's really two things that I like to tell customers about. You have to check for location, that it's there, and you have to also check that it's held almost like a safety.
Yeah.
Because you can have it right there where it's supposed to be, but have 10% of the hydraulic pressure you're supposed to have.
Right.
Or if something looks really good and you're just checking for location, you could do that with limit switches and things, and even vision. But if you don't have the pressure you need, so there's certain things you have to check for, and then you have to consider safety. Okay, you've got all this automated stuff going on. That robot doesn't know if somebody's standing there a lot of times, so you have to employ light curtains and lasers and things to make sure that everything's safe. But once again, it's all doable now. That stuff is all out there. It's down to the point where it's the average guy can afford it. You don't have to be a large automotive company or something, or an aircraft company, to afford automation anymore. It can be put into the small to medium-sized shop in a cost-effective manner.
Well, and that's the thing. Now, don't get me wrong. There were some big companies at Geyserfest and putting in big cells, big units, gantry-loaded robots or gantry-railed robots and things of that nature. But the overwhelming majority of the people I talked to were small shops, the under 50 employee type shops that were realizing, in order, one, to keep my shop going, to keep production going, or to meet demands, they've had to add machine capacity, but they're not able to add more employees. So they got to figure out, how do I add capacity, be more productive with the amount of people that I've got, and use these people in other aspects of my company, keep my company rolling. So vast majority of them were small shops.
Yeah, and it used to be, Wade, where if a company was going to automate, it would be for one particular process, and that's all it ever did. So this machine would be purchased for this process, this part, and that's all it did. And the robot would be purchased and put together and integrated for that part, and that's all it did. Now you can have a machine that does multiple parts, many parts, and a robot that can run and do multiple things too. So that robot is turning more from a single operation type of a thing to almost having like a real employee standing there. You can teach him to do this job, and then 2 months later you can teach him to do that job.
Yeah.
And it's people are doing it, and it's very possible.
So Arie, talk through one of the cells that I saw there, and I don't want to say enough to out a company, but the way the cell was set up, there was like 4 or 5 different parts running down the conveyor belt, and the vision system took a picture of it and figured out what the part was, called the program and all that. Kind of talk through, what does that look like, and is that something that people have access to? I mean, is that only for the big guys, or is that something that can be done at a smaller scale?
No, that can be done, and I think the cells that you're referring to were small cells. I mean, they were really 2 machine cells. You could put one between, and there was 4 of them that we built for 2 different plants. They started out, there are 2 machine operations, so the parts are coming in, they're forgings, in various different castings of multitude different sizes, and the recipes in there actually accommodate 500 different part numbers. So you think, to your point, Jack, about the different people that are out there looking for automation, and they think, well, I don't have a million of any one part. They run, 100, 500 different jobs, that are about 50 to 100 different pieces. That's what we're building for this customer, and we've done a lot of different things with our technology and our engineering staff that we have on site at Gosiger to make sure that the operator interface is very intuitive and easy to change over from that perspective. Like you mentioned, Wade, we have all these different fittings that are going in on on a conveyor, we're utilizing, and there's different colors of castings, right? There's different materials that we're utilizing. So because of some of the vision challenges, the lighting challenges that we have, we're utilizing a backlit conveyor. So we take the shiny reflectiveness, issues out of the equation from a vision perspective.
Okay, so deep dive that a little bit. What is a backlit conveyor for anybody that's not seen one?
So a backlit conveyor is actually putting lighting underneath the part or underneath the conveyor. So rather than utilizing a ring light around the vision camera inside the canister, it actually illuminates and kind of creates a shadow of the part for the vision to snap a photo of.
So the part is actually the dark pixels,
yes,
if you will.
Yes,
gotcha.
Absolutely. So that allows the robot to pick apart, and we don't have any contrast issues with shiny, silverish type parts or dark parts. It's consistent. And we're utilizing a deep learning camera there, so it actually it's artifact based, but it actually learns those pieces over time, and we're utilizing quick change part contact tooling, to your point earlier about people changing over different parts, and we do that all the time now. I mean, the changeover perspective is minutes rather than hours, or even tens of minutes. So you're calling up a program on an HMI, or using a quick quarter turn of your Allen wrench to pop the fingers out, pop the new ones in for the job, and you're closing the door and hitting cycle start. And that's what it is. And then the robot's utilizing external program select, and in Okuma's case, to call up the programs on the Okuma, to tell the machine what program we're running, and we're running 25 pieces of this and then 30 pieces of that. Those are all capabilities that anybody has, whether it's a small manufacturer or a large manufacturer. But that's what we're doing now. 5 years ago, there was a lot of systems that we would do for a lot of larger manufacturers. And a lot of those some of those would be one part, more of them were a handful of parts. Now to this point, and some of what we're seeing this year, it's far more common to build systems and cells around or for manufacturers that are, have 10 or 20 or 30 or 40 or 50 different parts. Right. Or maybe there's a handful of parts that we're developing a system for, case in point for the system you're talking about. But there's actually 500 different part numbers that cell is capable of running. And we're only executing the programming for a couple, but we're utilizing parametric programming so that we're entering that drawing more or less into a database, and it's utilizing those drawing dimensions to offset the robot, so the operator's not getting into the teach-dependent programming. Right. So it takes the manual intervention out of those setup processes even one step further. Yeah. Simplifying the operator involvement, and really reducing the changeover to the least amount possible.
Yeah. When you first asked me to put together a list of bullet points to talk about, and I started thinking of a title for my sheet, and I almost put the title down as Myths of Automation, because that's kind of what I want to talk about, was a lot of the things that over the years people get in their head, and okay, this is what it's going to take to automate. And maybe 25 years ago that was true, but now it's not. And the other one that I wanted to bring up here was the fact that people have this tendency to have this myth that it's going to take forever to get this thing set up and running. They say, well, okay, if we're going to automate, we're going to put a robot on, we're going to do all this, and I'm going to be setting this up and tweaking it for a year. That's a myth now. Yeah. That's just a total myth. I mean, you've got CAD systems now. You can simulate your programming with different types of CAM software, and the process, whenever it finally gets to the shop floor and you start setting this thing up, it's going to take weeks, sometimes days, and you're in production. Yeah. So that myth of, if I automate, it's going to be expensive, wrong. It's going to take forever to set up, wrong. I mean, if you get the right people involved and the process is defined right, and everybody understands what their role is, these things can go smooth, real smooth.
So let's kind of peel the onion, if you will, on a process that we actually just set up in conjunction with Jergens. We're doing a upper slide for a gun component. So we have your pyramid fixture. It's utilizing a ZPS type connection. So we've got 3 different vices. So we're actually doing the prep op. We're putting an op 10 in where we're cutting the dovetail. Op 20 is it's all progressive fixturing, right? So we're doing the dovetail, we're flipping it over to an Op 20. Pardon me, on Op 20, we're doing all of one side of the part. And then Op 30 is we flip it over, and it basically locates on the slide component of it. And they're finishing the part doing the Op 30. So every time the door opens, we get one finished complete part out. Right now, we set that up with the mindset of that would be a quick change, manually operated. This is a 5-axis machine, and we can very quickly open the doors, pop the 3 vices off, put 3 preloaded vices on, shut the door, hit the go button, and while that spindle's cranking out chips, I can be over here on the workbench and I'm flipping my parts. I'm progressing them to the next operation. That is a manual process, but that could very quickly become a AWR automated cell operation, right? So we can have drawers that the robot is grabbing these vices off of, loading it into the machine, dropping the fixtures that need to be progressed into a lower drawer. The operator on the outside of the cell opens the drawers, pulls his parts out, makes his changes, shuts the drawer, and it's ready for the next one. Am I going down the right road?
Exactly, Wade. I mean, if we had a picture of it here, you could show it, but all you would have to do to automate that process is right now, those vices, I believe, are bolted to the pyramid.
Mm-hmm.
All you do is put a ZPS module in between them, and now you can automate it.
Yeah.
So taking that process from what it is right now to full automation, I would think that Arie could figure that out probably in a week and have a quote and have the thing. We could actually be in there doing it probably within 6 to 8 weeks.
Mm-hmm.
You'd be up and running, and that was from the time they asked for it till the time they were making chips.
Yeah, so I think that's a great point to talk about as far as you have a manual fixture scenario where the parts are being manually fixtured onto those pallets, and you're putting that into the machine. You can take that one step forward and put a robot there to where all those pallets that those parts are staged on are inside let's say a drawer system or a cart. We're actually working on a system right now where we're doing that very same thing, where the robot, the operator is fixturing the parts onto the pallets, and this customer wanted to do that because they were castings. They never cut these parts before. They're unqualified castings, so they wanted to make sure that they're sitting on the pallets properly. This is their first endeavor in automation as well. So they're loading up all of these parts. It's a 2-op part. So they're first loading them up, and it's a pretty lengthy runner, about 35 to 40 minutes. But they're loading them up. We have 48 pallets in queue. The robot picks the pallet out. The robot reaches into the machining center. It's an Okuma Genos M465AX machine. You grasp a hold of the lever, pulls the lever to unlock the vise, pulls the other finished part out, and then loads the next one in. That's really the first segue into this, and then you can do that, and that works. That gets you some unattended runtime. You take it one step further, and then you go into a hydraulic or pneumatic clamping situation where the robot is picking raw work pieces out, whether they're saw cut slugs of some sort, or forgings or castings or aluminum die cast parts of some sort, picking those out of a material handling solution and then loading those directly into a hydraulic or pneumatic work holding solution. So that takes it even one step further as far as eliminating or reducing the direct labor content into that work cell.
Right.
So you have, like you talked about, the manual vices and loading those parts manually into the vise. Take it one step further where the robot's doing that, with unclamping a lever, unlocking the vise that way, and then going into one step further, the hydraulic or pneumatic work holding.
So those are really interesting points. One of the things that we really haven't talked much about yet is the inspection side of it. So a lot of times I'm thinking about getting parts in the machine, using the probe to figure out where the parts are, get the cutting process going. But talk me through a little bit from your guys' perspective on inspection, on making sure you're making good parts in the process.
Yeah, well, while the machines now with probing are capable of inspection, they really are. But the drawbacks on that is, one, you're using the spindle now for CMM, so it's not making chips anymore. And the other thing is you're using the machine itself to inspect itself, so it's like the fox guarding the hen house.
Yeah, and that's
so
a
lot of customers will say, well, and I agree with it, that you want to then take your parts out of the machine tool, put them into a quality control environment,
right.
CMM, gauging, whatever. So the inspection's going on. while the machine's cutting.
Mm-hmm.
And then you tie that all into your PLC, and if the CMM finds out that something's out of tolerance, it stops the whole process, tells you what's going on. You can even have it adjust cutter comp, make changes, work offset adjustments. All that can be done automatically. And then you can say, okay, well, once I make a cutter comp adjustment on this particular tool past 3 thousandths,
Mm-hmm.
I know it's time to change the tool.
Yeah.
Because that means it's worn. So all that can be figured into the automation.
Yep.
And it's not hard to do, and we do it all the time.
So you bring up a great point, and you haven't had a chance to listen to it yet because we just recorded. We haven't got it rolled out yet. But the previous podcast, we actually talked about carrying Autocomp, for an example. That's a great way. That's the conduit, if you will, from any kind of inspection device to anybody's tool offset, not just Okuma. Any machine tool builder out there can utilize that, again, to eliminate that intervention of the operator.
Mm-hmm.
Yeah, so there's a couple of different options that we have. I mean, automation's great for making, a lot of parts, but, if you don't have the proper checks and balances in place, you can make a heck of a lot of bad parts too.
Yeah.
So, post-process inspection is key. And, there's a couple of different things that we can do in terms of post-process inspection. One of those, and probably the most cost-effective for, maybe a job shop manufacturer, is just loading the part into, pulling the part out of the machine, going through an air blow-off situation, and then loading the part into what we call an audit drawer. That can be set up on an interval, or that can be set up by request via the HMI that we put into our cells. That allows the operator to open that drawer on an interval or by request and inspect that part for quality, making sure that the part that you are making is in fact a good part. So that's one option there. The other options we have is going a little bit further in terms of comparators or shop floor CMMs, even vision inspections that we're doing now. Those pieces, inspection pieces of equipment, have come a long way in terms of reliability, as well as cost effectiveness and changeover. Like anything else, right? There's very few manufacturers out there in the marketplace today that are making 1 million of one piece. Mm-hmm. Many of them are making more or less low volume, high mix type applications. But to your point, Wade, in almost every single occasion where there's some sort of post-process inspection, whether it be an equator of some sort, a comparator mm-hmm. of some sort, or a shop floor CMM, Karen Engineering, Autocomp, and TMAC is almost always utilized, and if it's not, it should be.
Right.
That's a tremendous tool.
So one last point, and we'll wrap it up. I know we're probably a little over our 30-minute mark that we try to aim for, but one of the things I saw at Geyserfest was a vision system that was doing some inspection, doing visual inspection of a part to make sure, I think it was an ID thread or something along those lines. Tell me a little bit about that, and what are some of the applications that could be used in?
Really, we're just scratching the surface. I mean, that can be utilized in a multitude of different scenarios. The reason why they're utilizing it is it's a cast part. So it's a cast part, and with cast parts, oftentimes you have porosity issues.
So the vision will pick up porosity in the part
yes.
before it's cut, or after it's cut,
so after
and
it's
then
cut.
Kick it off so it doesn't wind up in a customer's bin.
Yeah, because the challenge that they were faced with before is there's operators manually inspecting those. Well, there's an operator saying that they're inspecting every single one. In reality, too many parts that are failed parts are making their way to the customer. Mm-hmm. Then they have to pay to ship them back, and then ultimately remelt them, recast the parts. So we're utilizing the vision inspection there to check. We actually have 2 cameras set up to check a couple of different features. We're making sure that the machine parts or the machine surfaces don't have porosity in them. We're also making sure that there's an oil hole that's present. And then we're also making sure that the drilled features are in fact drilled and they are in fact tapped, and that there's not a tap broken off in them. So that's the first, after the machining process, that's the first line of defense, and if it doesn't pass that, then it gets kicked out. From there, it goes into, a Renishaw equator for some measurement and utilizing some Karen Engineering for Autocomp, and then on to, some assembly processes that we're working on there, and then ultimately pack out for shipment.
Okay, excellent.
Yeah.
Well, guys, I really appreciate your time today. Jack, always a pleasure. You're a wealth of knowledge. If anybody needs to get a hold of you or Jergens to learn more about Workholding, what's the best way to get in touch with you?
I would say start off with the Jergens website. Mm-hmm. www.jergensinc.com, and go in there. You can find phone numbers and things, and you can get in touch with me right through the website.
All right. Arie, how about you for Gosiger Automation?
The same thing. Our www.gosiger.com website is a great tool to look at and reach through out through the website there, or automation within reach. Create an inquiry online. Most of those come to myself, and then we can figure out who the best person to talk to for the area that you're in.
All right. Well, thanks for being here, guys. I really appreciate it. And thank you for joining us. If you've got thoughts or ideas for future podcasts, any content you'd like to hear more about, reach out to me on LinkedIn, Wade Anderson on LinkedIn, or you can get a hold of us on Okuma.com. Be sure to check out our YouTube channels for additional machine content and other video features.